Welcome to Cookie's Maths and Science Hub. Today we're going to be exploring radiation and its three main types, alpha, beta and gamma, as well as some of the properties of radiation. So, what is radiation? Well, radioactive decay, also called nuclear decay, is when an unstable nucleus emits radiation and is transformed into the nucleus of one or more other elements. It does so to make itself more stable. Such unstable nucleus are often due to being unstable isotopes. Remembering isotopes are atoms of the same element with varying number of neutrons, and these are unstable usually due to having a higher number than the standard neutron number. If you need a bit more of a refresher, check out our isotopes video before going any further. This radiation can be emitted in many different ways, but we're going to focus on three distinct ways in this video: alpha particles, beta particles, and gamma rays. Up first is alpha decay. During alpha decay, which is often given the symbol alpha in Greek letters, an unstable nucleus ejects a relatively large particle known as an alpha particle. This consists of two protons and two neutrons, and is often so called the helium nucleus, as it's the same thing. So we have our parent nucleus, which is unstable, gives off our daughter nucleus, and ejects an alpha particle. A beta particle, as with alpha, given the letter beta from the Greek alphabet, is an electron ejected from the nucleus, not from the shells of electrons about the nucleus. Now this can be a bit confusing, as with our basic understanding of the atom, electrons aren't within the nucleus. So what actually happens in this process is a neutron becomes a proton and an electron, with the electron of those two then being ejected to return stability to the atom. There's a lot of different processes that occur during this stage, but for now, we're just going to focus on the ejection of that beta particle. Gamma decay, once again given the symbol gamma from the Greek alphabet, is unique when compared to alpha and beta, as rather than a particle, it emits a photon, or a wave of energy. Gamma emission occurs after another form of nuclear decay has taken place most of the time, as following a decay, the arrangement of protons and neutrons in the nucleus of an atom may not be ideal and still be unstable. So the nucleus may need to release some extra energy to become more stable in the form of that photon. By doing this, it then becomes stable. So there is less change to the overall structure of the atom, but it's still releasing that excess energy. Now that we've explored each type of radiation, let's look at some of the basic properties. One of the most important properties is the penetration power of each type of radiation. This is simply the ability of each type of radiation to pass through matter. The more material the radiation can pass through, the greater its penetration power is. Terms around this penetration that are important are also ionizing power, as well as the shielding provided for materials. As you can see in our little diagram, alpha has the least penetrating power and can be stopped by simple paper. Beta can be stopped by wood, and gamma can be stopped by much more dense materials such as lead. Looking a bit more in depth at some of those terms, the ability of radiation to damage molecules is analysed in terms of what we call ionizing power. The ability of each type of radiation to pass through matter, as we stated, is penetrating power. The shielding is simply the material type and amount required to prevent penetration by this radiation type. So we might say the shielding required for gamma is greater because it has greater penetration power. So, when we talk about ionizing power and the dangers of radiation, what does that actually mean? Well, ionizing radiation may cause severe damage by breaking bonds or removing electrons in biological molecules. Most importantly, when we talk about ourselves, our DNA, which can disrupt their structure and function. Non-ionizing radiation, on the other hand, which isn't our alpha, beta, gamma, but is some other types of radiation, is simply going to absorb the energy and speed up the movement of atoms and molecules, which is the equivalent to heating the sample. So in this case, the most common one of these that people often talk about is microwaves. For microwaves use a form of radiation, but it is non-ionizing radiation, which means we're not radiating our food every time we heat it up in the microwave. A large amount of non-ionizing radiation is necessary before dangerous levels are reached. Below is listed some common sources of ionizing and non-ionizing radiation types. Now, I would like to draw attention back to those three types we've explored: alpha, beta, and gamma. We know that alpha has the least penetrating power, as it can be stopped by simple paper. But it should be noted that the order of penetration, meaning alpha is the least penetrating to gamma being the most penetrating, is actually reversed for ionizing, with alpha being the most ionizing, then beta, then gamma. This is why we often talk about in science questions you might come across in your papers, ingesting alpha is the most dangerous because that means it can directly ionize your insides. Normally it can't penetrate our skin, so an alpha source might not be dangerous outside of the body. Thanks for watching. Hopefully now you have a good understanding of radiation and the three main types of alpha, beta, gamma, and some of the properties involved with those types of radiation. Be sure to like, share, and subscribe, and keep an eye out for further science and maths videos. Hope to see you back on the channel soon.